Hey everyone, welcome back to Math 208. So in this video, we're going to be looking at Chapter 2, which is the chapter on quadratic functions. So we'll talk about what quadratic functions are, how they're different from linear functions, and then we'll do some applications of it as well. So a quadratic function is a function of the second degree, meaning that its highest exponent is a 2. Versus a linear function, which was an equation of the first degree, where the highest exponent was a 1. So if I compare them, a linear function would be something like y equals 5x plus 10, where the exponent, the highest exponent, is a 1. A quadratic function is 5x squared, let's say, plus 2x plus 10, where the highest exponent is a 2. The shape is also different. So a linear equation we saw in the previous chapter is a straight line, whereas a quadratic equation is a parabola, which you can see over here. Okay, so that is the subject of today's chapter. So a parabola has just a couple of things. It has the vertex, and the vertex is either the highest point or the lowest point, but it's basically the peak or the bottom of your parabola. It's called the vertex, and the coordinates for the vertex, we call them h and k. H being the x-coordinate, that's h, and k being the y-coordinate, k. Okay, keep that in mind because we're going to be using some formulas that will require you to remember that. The roots of the parabola. The roots is just what we call the x-intercepts. It's where your parabolas hit the x-axis if they do at all. So for example, this one has, I mean, you can't really tell, I guess, but let's say you've got, let me just go here, right? So sometimes you have a parabola that actually crosses the x-axis. So a parabola can have two roots. So that would be 1 and 2. Okay. A parabola can have no roots at all, technically, right? You can have a parabola like this, for instance, that never hits the x-axis. And then there are no roots. Or it could have one root where it touches where the vertex is actually on the intercept. Okay, so those are your three situations. Don't worry, we'll see them as we go. For now, we're just talking kind of in a basic way. We're going over what the different terms mean. So the roots are the x-intercepts. You can have 1, 2, or none, and the vertex is the point at the top or at the very bottom of your parabola. Okay. The quadratic equation, a very, very, very important equation, is how you find the roots. Okay, x, so the roots, can basically be found by using this formula. So, and you'll know just from you trying to do it whether you're going to have 1 root, 2 roots, or 0 roots. Okay, if the number under the square root is negative, okay, so I'm going to write it here. If b2 minus 4ac, okay, is less than 0, so negative, it means there are no roots. Because you cannot square root a negative number, so you would have no x-intercepts. If the number under is equal to 0, you have just 1 root. You have 1, so the vertex in that case would land squarely on the x-axis. And if it's positive, that's where you would have 2 roots. Okay, so keep that in mind as we work through the exercises of what it means when you get a number under there, whether it be positive, negative, or equal to 0. Okay. Just like the linear equation, the quadratic equation has a standard form, which is very similar, right? ax squared plus bx plus c. Or it can have a vertex form where we see the vertex directly in the function. So you see here, this is the vertex form. You usually have a here, that's your constant, and that's going to tell you whether your vertex is smiling or frowning, right? So if, I'm sure it's written here somewhere, but if it isn't, yeah, here. So look, if a is greater than 0, okay, then you have a minimum. So for example here, if your a is greater than 0, if it's positive, then your equation is frowning. Sorry, not frowning. If your a is positive, your equation is smiling, right? So if a is positive, your function is smiling. If A is negative, your function is frowning. Within the bracket, you have your h, okay, which is the x coordinate of your vertex. Remember that vertex is h and k. And then over here, you have your y coordinate, okay? So we'll go over all these in a second. And then finally, very important, you have your vertex formula, okay? This is how you find your vertex. So we're going to go over how to do this in just a second. So to find the h, right, the b and the a that they're referring to is in the standard form. So often it's written this way, ax, just using lowercase, just so you guys see that it's pretty much the same. Okay, so it'd be the b and the a in the standard form. And other things you want to know, I guess, is that the c here in the standard form is the y-intercept. Again, if you were to set x to 0, that would wipe out both a and b's little blocks there, leaving you just with c. Okay. All right. Oh yeah, it was written here. Okay, let's get into it. These little details here, we can work through them as we start solving exercises, but very quick. The domain, okay, so remember that domain is the values of x that are possible. And when you're dealing with quadratic functions that are basically a parabola, they go from infinity to infinity on the x-axis, right? So if you think about the x-axis, the parabola will go from negative infinity to positive infinity. But for the y-axis, which we call the range, okay, it does not. It really depends on if it's frowning, so frowning or smiling, and so if it's a parabola like this, then at the vertex you have the maximum. The y value will never exceed that. So it goes from this maximum all the way down to negative infinity. That's what I wrote here. If your a is positive, you'd be smiling. So your domain is from your vertex up to positive infinity. But if your a is negative and you're frowning, then your domain, your range is from negative infinity, but only up until the, like in this case here, right? Only up until that maximum. So that might seem overly technical, but as we start working through some exercises, you'll see that the graph basically tells you exactly what you're supposed to do for that. So the first thing I want to go over with you guys is how to complete the square, which is a factoring technique. You may have learned it before in Math 206 or even in high school or in CJEPs. So in order to convert the standard form to the vertex form, you want to complete the square. You want to factor by using that method. So I'm going to zoom in here, and this is how you do it, guys, step by step. First, you want to take your b, right? So remember that it's ax squared plus bx plus c, right? You want to take your b coefficient, so in this case positive 2, and cut it in half. So you're going to take your b and cut it in half. So that would be, in our case, 2 over 2, so 1. And then you want to open a bracket, so it's x squared, okay, plus 2x, which is just this. And then you want to take this half and square it. So if I take 1 and square it, that gives me 1. And I'm going to add that to the end. But in order for you not to change the value of the equation, you can't just add a 1. What you also want to do is subtract 1 right there, and then plus 4. And you're looking at that and saying, well, what was the point of that? You'll see, okay? Now, because you have it because now we're going to focus on this part, okay? This now is a perfect square. So x minus 1, x plus 1 square. X is from here. The plus 1 is from here. And then over here, minus 1 plus 4 is just plus 3. So that's it. You've completed your square. You have it in slope, vertex form, I mean. And the vertex, if you want to find the vertex, you take this number here. But you want to be careful. Remember that the vertex form says minus h. So whatever the sign is inside the bracket, the vertex is actually the opposite sign. So your x-coordinate is -1. And then the y-coordinate of the vertex, you just take whatever number you have out there. So this would be the vertex. If you want to check that you did it right, okay, remember the formula to find your h, right over here, minus b over 2a. Just try it out. So take your minus b, which is, in this case, negative 2, over 2, and your a here is a 1, right? There's a 1 there. So minus 2 over 1 is minus 2. Minus 2 over 2, sorry, is minus 1. So I know that this is right. And then take it and plug it back in. So this is x, right? Plug it back in just to see what you get. So if my x is minus 1, it would be minus 1 squared. I'm plugging it back into my original equation, plus 2 times minus 1, plus 4. So this is 1, this is minus 2, and this is plus 4. That gives me 3. Oh, so I've basically confirmed that my vertex is minus 1 plus 3. That gives me confidence that I completed the square correctly. So check. So let's do another one. I want you guys to pause the video and try and do this one on your own. Follow the exact same steps. Rewind the video if you need to, okay? So let's get into it. Now, when you're completing the square and you have a value in front of your x-axis, variable, the first thing you want to do is factor that out. So here, before I get into the completing the square business, I'm going to factor this 3 out of those first two. Oh, there's an x missing here. I'm going to factor that 3 out of those first two. So that would be, if I pull the 3 out, x squared here minus 4x. Okay? That's kind of your step 1. Now you want to start completing the square. So what did we do before? We take that value, that minus 4, cut it in half. That gives us minus 2. Then we want to take that number minus 2 and square it. That gives us positive 4. So same thing we did before, okay? 3 x squared minus 4x. And now we're going to add 4 and take away 4. Okay. So what do we have here? We have here a perfect square. So that would be x, remember you take this number, so minus 2 squared. You still have the 3 in front, so you leave that there. But then this little minus 4 has got to go somewhere. So because it's within the bracket, you need to multiply it by the 3. So 3 times minus 4 is minus 12. And then minus 7 at the end of the bracket. So now if you clean this up, you've got minus 12 minus 7, which is minus 19. There's a square here, and there's your answer. You have your vertex, so it'd be, remember, take this number, switch the sign, so 2, and then take this number as it is. That's your vertex. And then, again, be paranoid. Take that result, plug it back into the original equation, and see if you can get to that same answer. Okay? Or rather, yes, you can do that also, but use the vertex formula, so b over minus b, minus b over 2a. So your minus b here, I would take the 12, but flip the sign, so it'd be positive 12. And then my a was 3, so 2 times 3. 12 divided by 6 is 2, which is what I had here. Then take that 2, plug it back in. 3 times 2 squared minus 12 times 2 minus 7. This is a 4, so 12 minus 24 minus 7. That's minus 19. So I know my vertex is right, which gives me confidence that I completed the square correctly. So before we move on from this, little key things to remember. When you take your b here and you cut it in half, this is the number that will end up being your, like here, in your completed square. Don't forget that if you have that number within the bracket with the number in front, that you need to distribute that 3 into that 4. And that's it. If you always follow these steps, you shouldn't ever have trouble completing your square and getting your vertex form. Okay, you guys will let me know on Discord if you have any questions, so let's do another one. Now we've given you this quadratic equation. So again, I have my A. This is A here. B is -6, and C is 21. Okay. Find the x and the y intercepts algebraically. So it's the same idea here in any function when you want to find the x or the y intercept. The x-intercept, you find it by setting the y equation or the function equal to 0. And then the y-intercept is found by setting the x equation equal to x variable equal to 0. So let's start with the x-intercept. If I want to find the x-intercept, I'm going to write out the equation, leaving x as it is, but setting that equation equal to 0. Remember that f of x, that's like your y. Okay. So to solve this question, like this, you want to use the quadratic equation. This is when you use that. When you're trying to find the roots, and remember what the roots are. The roots are the x-intercepts. It's when you want your quadratic function to equal 0. So I'm going to use I'm going to go and grab that formula from earlier. Okay, so paste. So let's begin. Minus b, so b is already negative, so that would become positive. So 6 plus minus square root of -6 squared minus 4 times a, which is half, c, which is 21, okay, over 2a. And the first thing you want to check is that that value inside of the root. So I'm going to punch this bit on my calculator without the square root. So -6 squared is 36 minus 4 times a half times 21. I get -6 inside that bracket, inside that square root. So I can stop right away because I know that that number, if it's negative, cannot be solved. So I'm going to say there's no x-intercept. There's no x-intercept. There's no value of y that can make x equal to 0. The function, if I were to graph it, will never cross the x-axis. For the y-intercept, you take the function again, and you set the x equal to 0. So I'm just replacing all my x's here with 0, and that'll give you just that c value, right? This goes away, and that is your, all right, that's f of x. So that's your y-intercept. So there's no x-intercept, but the y-intercept happens at y equals 21. Okay, so that's A. B, the vertex form. So for this, we need to complete the square. Again, you guys should be trying to do this on your own. 0.5 x squared minus 6x plus 21. So again, because the x here has a coefficient in front, we're going to start by factoring that out of the first two terms. So if I take the 0.5 out, right, I'm left with x squared. And here, if you're wondering, like, well, what do I do with this? Remember that to factor out, you're just dividing. So 6 divided by a half is 12. You can punch that into your calculators. Do 6 divided by 0.5. So here I get minus 12x. Okay, so that was my first step. And then we'll do what we did before. We take that negative 12, we're going to cut it in half. That's negative 6. Then we'll take that negative 6 and square it. That's 36. So to complete the square, within the bracket, we're going to add and subtract 36. So plus 36 minus 36. Okay. Here we have a perfect square. Okay, and then we have that 21 kind of sitting outside. Okay, now we start putting it together. So since this is our perfect square, remember that this number is what you're going to use. So minus 6 squared. Then you'll take this half and distribute it there. So a half times negative 36 is negative 18. The 0.5 is still in front, and the 21 is still at the end. And then you just clean it up. Put these two together. So my answer is 0.5, x minus 6 squared. Minus 18 plus 21 is plus 3. So there you go. That is your vertex form. Okay, great. So then we've got C, which is find the vertex and the max or minimum. So now that you have your vertex form, the vertex, you can just see it. It is 6, so we always take the opposite sign, and 3. And then is it a maximum or a minimum? Well, remember that you want to look to A for that. Since our A is positive, okay, so since A is positive, we know that it's smiling, which means it has a minimum. So the minimum of this equation is always the y coordinate of your vertex. Same with the maximum. The maximum would also be the y coordinate of that vertex. Okay. And then the last question, find the range. So the range, remember, is all the possible values of y. So if you look at your graph, I'm saying that this bit here, this minimum, is at 3, and it goes up to infinity. So the range is 3. You want to include the 3, so I put a square bracket, all the way up to positive infinity, and you could put a round bracket for infinity since you can't include infinity. So that's the range. That would be in what we call the interval form. You can also write it in the as an inequality, so you can say that y is greater than or equal to 3 and less than infinity. Okay, that also works. You can also just write y is greater than or equal to 3. You can write it this way, y is greater than or equal to 3. Okay, that would be your, all of these would be fine for the range. Okay. And again, just to make sure we understand the difference, had my A been negative, okay, going off on a bit of a tangent here, but let's say my A had been negative and it had the same vertex, just to keep it simple. Well, then your range would have been minus infinity up until 3, like this. So your range would have been from minus infinity to 3. If you wanted to write it in the different form, your y would be less than or equal to 3. In both cases, guys, the domain, had they asked it, would have been negative infinity to positive infinity because your x values can take any real number. Okay, was there a D to this question? Oh, that was D. Okay. So the vertex was C, and then the range was the range was D. Okay, great. Now that you kind of understand the math behind the quadratic function, we can start to apply it to situations, and this is where we start to get into possible exam questions. The same thing we saw in the previous chapter with price and revenue and profit and all that good stuff can be applied to this situation. And what changes is when your price becomes a function rather than a constant, then your revenue will also change. So we saw in the previous chapter when it was linear that if price is a constant, then your revenue is a straight line. But if your price is a function of your output, then your revenue becomes a parabola. And instead of having only one break-even point, you often will have 2 because your revenue will cross your cost equation twice. Your profit function also goes from being a straight line, which we saw in the previous chapter, to also a parabola. And pay attention, look, at your break-even point is where your profit is equal to 0. And something that you need to understand is that the output, so the quantity that maximizes your profit, is not necessarily going to be the same as the quantity that maximizes your revenue. Okay? So you want to just pay attention to that. Are they asking you to maximize revenue? Are they asking you to maximize profit? Read your questions carefully because that'll determine what you're looking for. Okay? What else is important here? Profit and loss regions. If ever you get asked that question, it's pretty simple. You're making money. You're profitable between your break-even points. So if I could shade it in, okay, this is your profit region. It's everything between your break-even points. And what I just shaded, that's your profit. You're losing money on the outside of your break-even points whenever your cost exceeds your revenue. That's where you're losing money. Okay? So let's get into it. Here's an exam question. It says an electronics manufacturer, an electronics, something that I'm missing there. Anyways, an electronics company, let's say, manufactures and sells mobile phones and has established the following price demand functions. And cost functions. Yeah. So you see, your price is not a constant. Your price is a function of output, meaning that the price will change depending on the amount of units you're going to sell. Okay, and that's the big difference between this one and the previous chapter. Then it says where price is the wholesale price in dollars at which X thousand, so X is in thousands. Revenue and cost are in thousands of dollars. Both functions have a domain of 0 to 20. So they're basically limiting your output to 0 and 20. You're going to produce between 0 phones and 20,000 phones. And let's get into it. A, find the output that would produce the maximum revenue and compute that maximum revenue. Okay, very good. So to answer the first question, let's start by finding our revenue function. And we learned in the previous chapter that revenue is price times quantity. Okay, so they gave you the price function. They said that it was 80, what did they say? 80 minus 4x. That was price. So that times quantity, your revenue becomes a quadratic function, and that's what gives that its shape, that parabola. Okay, so look, I zoom in here, let's distribute our x. So x times 80 would be 80x. X times negative 4x would be negative 4x squared. Okay, and we could rearrange this just to put it in order. So minus 4x squared plus 80x. Okay, good. Now, if they want to find the point where revenue is maximized, what we're asking you for is the vertex, because your revenue does something like this, right? It goes up and then comes back down. And so it's maximized at the vertex. So we're going to take what we learned earlier in the chapter. This will give us the h, or the x coordinate of the vertex. So your b here is 80, so I'll do negative b, negative 80, over 2 times negative a is 4. A is negative 4. So minus 80 divided by minus 8 is 10. So I know that the x coordinate of my vertex is 10. The y coordinate, you just plug it back in. So if you want to find the actual maximum revenue, just take that value and plug it in. Okay, so we're going to plug in our x. 80 times 10 minus 4 times 10 squared, 400. Okay, so now when you're answering the question, guys, it's really important that you answer it properly. So you got 10 and 400, but the answers are, remember that both x, which was your units, and the actual revenue are in thousands. So the actual answer is, this is x, right? 10,000 units would maximize the revenue, and the maximum revenue is $400,000. So just make sure that you're entering it in thousands. If it's in thousands. Okay. Now B. Find the break-even points. So to find the break-even points, we're going to take the same approach that we did when we were doing just the linear chapter. The break-even point is where revenue equals cost. You can also find it as the point where profit equals 0, guys. It's the exact same thing. Okay, so our revenue function, we have it. It's what we just said, 80x, or rather this one here, minus 4x squared plus 80x, so minus 4x squared plus 80x. And your cost equation, have they given it to us? Yes, 280 plus 4x. And you solve. Now, what's going to end up happening here is you'll have to use your quadratic equation, because in order to solve a question like this when you have that square, what you want to do is bring everything over to one side. So that means I'm going to bring both of these into this side here. So I have negative 4x plus 80x minus 280 minus 4x equals 0. And then just group your like terms. So 80 minus 4. So minus 4x squared plus 76x minus 280. And now you can use your quadratic equation. So minus b plus or minus the square root of b squared minus 4ac over 2a. Okay. So negative b, so negative 76 plus minus the root b squared, so 76 squared minus 4, a is negative 4, c is negative 280, and then that whole thing over 2a, so 2 times negative 4. Great. Let's start with inside the square root, so 76 squared minus 4 times negative 4 times negative 280. 1296, and then we're going to square root that. 36. Okay, it just makes it easier to do it one bit at a time. So now I have minus 76 rather, plus or minus 36 over negative 8. So we'll do it once with plus and once with minus. So negative 76 plus 36 divided by negative 8 is 5. So that's your first one. So x1 equals 5. And x2, negative 76 minus 36 divided by negative 8 is 14. So those are your two break-even points. If I were to go back to my graph from earlier, that those are your 2 points here. So what do we say, 5 and 14? It means that exactly 5 here and at exactly 14, those numbers obviously don't match with the graph. Your revenue equals your costs, and so your profit would equal 0. Those would be your break-even points. Okay. C. Let's give ourselves some more room here. For what output will we incur a loss, and for what output would we turn a profit? So remember what I said. You earn a profit between your break-even points, but you don't want to include them. So I would say you earn a profit if your x is greater than 5, but less than 14. That would be if you wanted to use the inequality, or you can use the interval form, which is 5 to 14. Now, why am I not including them? Because at 5 and at 14, you don't have a profit. You don't have a loss either. You're breaking even, right? So technically, you don't want to include those. Same thing with the loss. The loss happens before 5. So if you sell less than 5 and if you sell more than 14, now you want to be careful here because in the context, you don't want to go all the way to infinities. You can't sell infinity units, and you can't sell negative infinity units, which is why we gave you this domain here. This is basically everything. Nothing should exist outside of this range. So we're going to say here that you would incur a loss between 0 and 5. Include the 0. Do not include the 5. At 0, you would actually lose money. At 5, you would break even. Union. So that's just to combine two intervals that are not adjacent, that are not touching. From 14 to 20. That would be your interval form. The two areas, am I in the camera? The two areas outside of that range. And again, if you prefer to use, I would probably go this way. If you want to use the inequality form, you'd have to say something like, if x is, you still have to do a union. It'd have to be like between these two. So I think the interval form is probably the best route to take here. So let's just go with that. Okay. And then finally for D, what was D? Sketch the graphs of the revenue and cost in the same coordinate system. Okay. So let's give ourselves a lot of space to work here. So we know the domain is 0 to 20, so let's see if I've given myself 20. So this would be 5, 10, 15, 20. Okay. What did they say to sketch? They said to sketch the graphs of revenue and cost. Okay. We know the vertex of revenue is at 10 on the x-axis and 400 on the y-axis. So I know I need my y-axis to go up to 400. That's the highest it needs to go. So let's make this, let's go here. Okay, let's just make this 400 up here, which will make this 200. And so my vertex happens right there. Okay. Okay. Now, to sketch your revenue function properly, well, here's the thing about revenue. Our revenue was negative 4x squared, right? Plus, what was it? Plus 80x. Notice how there's no c. The c is 0. It's like saying plus 0 here. Remember that this is your y-intercept. So I know that I have a point right here. And so if I have a point right there, my peak is here. The other time, and it's a parabola is symmetrical, I know that this is going to come up and then come back down. So it's going to cross here and then come right back down and hit directly on the 20. Okay, so I think with the iPad I'm able to make a parabola if I could just get it to work. Okay, well I give up on that. Okay, look, so like this, it hits the vertex up there, and then it comes right back down to the 20. It's perfectly symmetrical. If this is the center of the parabola, and this is 10, right, from here to here, well, then this also has to be 10. And that's always going to happen with these revenue functions. Now, your costs. The cost equation was 280 plus 4x. Okay, so 280, that's your intercept, right? That's your fixed cost because you're going to incur that even if your x were 0. So 280 would be somewhere here, right? So if that's 200 and that's 400, that means I'm jumping by 40. That's perfect. So 280 would be right there. And now you need a line. What I like to do is take the end of my domain, which was 20, and plug it in. So if I plug in 280 plus 4 times 20, that would be 360. And so 360 would be right around here. And then we'll just connect those dots like this. Bingo. And if you've done it right, look at where they intersect. I mean, my parabola is not perfect, but one of my break-even points I think was 14, so C hits it right there. That makes sense. And the other one was 5, which is here. Now that's because the shape of my parabola is not perfect, but if it were, then it would, it would cross it directly on this line here. Okay. So that is it for that question. This is what an exam question looks like when you do get tested on this, typically 4 parts. Will they ask you to sketch or not? Maybe, but you want to know how to do it. You want to be able to find your break-even points. You want to be able to find, answer the range of profit and loss, and that should get you all your marks. Okay? So that's it for this video. The next video, we're going to get into some other types of functions like exponential functions and logarithmic functions. But we will stop here. I want you guys to practice this because this is a very common question on both the midterm and the final. So spend a lot of time on this, get used to it, do it to the point that it becomes annoying and repetitive, and you will get all your marks. Okay, if you have any questions, Discord, please find me there. You can find our Discord at the very top of our website, the little Discord logo. I'll speak to you guys over there. Okay, thank you so much. See you next time.